This is going to be a series of 4 videos where we explore indeterminate forms and L'Hopital's rule. There are 4 different types of indeterminate forms: indeterminate quotients, indeterminate products, indeterminate differences, and indeterminate powers. Oops, missing one. All right, in this video we're going to be looking at indeterminate quotients, and those are limits of quotients of where the top is going to 0 and the bottom is going to 0, or the top and bottom are both going to plus or minus infinity. And in problems previous to now, when we ran into this situation, we would do more work. And we are going to do more work still, but I think you'll find this work is relatively painless. All right, let's look at an example where the limit as x approaches a of the quotient f of x over g of x is of the form where the top goes to 0 and the bottom goes to 0. Notice I do not write equals to 0 over 0 because that doesn't make sense. Okay. Now, what we're going to do here is we're going to look at what happens near a. Okay? If I were to take a microscope and zoom in onto a and look at both f and g, they both would look very linear. And f would look a lot like this line, which is the tangent line to f at a. And remember what that is. That is y minus f of a, which equals f prime of a times x minus a. That's the equation of the tangent line to f at a. And in this case, f of a is 0, so y equals f prime of a, x minus a. That's the tangent line to f at a. And more importantly, what I just said was as x goes towards a, f of x looks a lot like that line. Okay? As x goes towards a, f of x looks a lot like its tangent line at a. Likewise, if I zoomed in and looked at g, I would see that g looked a lot like this line. And that line right there is its tangent line at a. And we could write that pretty quickly. So y minus g of a equals g prime of a, x minus a. Okay? And likewise, g of a is 0, so really y equals g prime of a, x minus a. So that's the tangent line to g at a. All right? And we can make the same conclusion here. As x goes towards a, g of x looks a lot like its tangent line at a. Okay? So that's actually going to help us here. All right? So if we are looking for the limit as x goes to a of f of x over g of x, and we're saying that f is about this line right here, as x goes towards a, we could say that this is equal to the limit as x goes to a of f prime of x times x minus a over g prime of x times x minus a, right? So kind of looking at it this way, f of x equals its tangent line. G of x equals its tangent line is not really what we're saying. We're saying that as x goes to a, f looks more and more and more like the tangent line at a. Okay? Now that's pretty nice. These cancel, and so what I really have is this statement right here, which says the limit as x goes to a of the quotient of two functions, if it's in indeterminate form, equals the limit as x approaches a of the quotient of its derivatives. And that's really nice. Now this example was when we were an indeterminate quotient of the form 0 over 0. This actually holds true if we are in the form infinity over infinity, plus or minus, plus or minus. Okay? And so what I have right here is the statement of L'Hopital's rule. Right? So if you have an indeterminate quotient, then this limit is true, or this equation is true. All right? Now let's actually see that in action. All right? Let's look